Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to simplify radical numbers and how to perform various operations on radical numbers. How are we learning it? Through the Radical Numbers Part 1 notes and Radical Numbers Part 1 assignment. When can we use this? To determine the dimensions of a housing lot, given the square footage, to determine whether or not furniture or additions will fit. How do we know if we learned it? By getting a score of 4 on the Radical Numbers Part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed the Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Radical Numbers Part 1 notes, and then I'll give you time to complete the Radical Numbers Part 1 assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we will go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Irrational Numbers study guide and any incomplete assignments that you may have. Let's take a look now at the Radical Numbers Part 1 notes. Our notes begin with the learning goals and success criteria. Now, what are the types of roots? There's the square root, which looks like this, the square root of n, and it's some number times itself equals n. So for instance, the square root of 64 is 8 because 8 times itself is 64. So that's the square root. Then there's the cube root, and it looks like this with the little 3 over the square root symbol. And this means we're taking a number and multiplying it by itself 3 times. Fourth root is 4 times. Fourth root is 4 times, and we could keep this going. We could do the 5th root, 6th root, 8th root. As far as we want to go, we can continue this on. So now how do we simplify roots? Well, we first want to see if it's a perfect square. Well, 9 is a perfect square, so we can take the square root of that. And that's really 3 times 3, right? 9 is 3 times 3. So when we pull it out, we should pull the 3 out because it's 3 squared. So the square root of 9 is just 3. Now let's look at the cube root of 8. Well, 8 is really 2 times 2 times 2. So it is a perfect cube because it's 2 3 times, right? So it's 2 to the 3rd power. So we can pull that out and our answer then would be 2. Now what happens if it's not a perfect square or perfect cube or whatever we're looking for? For instance, 8 is not a perfect square. Well, we can see that it is 2 times 2 times 2, right? So we do have this first part in common. This is a 2 squared times 2. So we can pull that 2 out from the 2 squared, and we're left with 2 square root of 2. Now what about the cube root of 54? Well, we should notice that 54 is really 3 times 3 times 3 times 2. So we can keep this first part because that's 3 cubed. So we can just pull that 3 out, and we're left with then the cube root of 2 over here, and we pull out the 3 here, so we end up with 3 cube root of 2. Now simplifying root expressions. So we have 3 square root of 2 plus 5 square root of 2. Well, as long as we have the same root, we can treat that like it's a variable almost. And that means that we can combine those like terms. So we'll add the coefficients and keep the variable, or in this case, keep the square root. So this becomes 3 plus 5 is 8 square root of 2. Now when we multiply, so we multiply the coefficients and then multiply the roots. So in this case we have 2 times 1 in reality, because this is 1 square root of 5. 2 times 1 is 2. And square root of 3 times square root of 5. So we end up with 2 square root of 3 times 5. And 3 times 5 is 15. So it's 2 square root of 15. Now, a couple of formulas that you'll need for today are difference of squares. So difference of squares says that we start with a plus b times a minus b, and that's equal to a squared minus b squared. And this also works in reverse. So if we started with a squared minus b squared, that's equal to a plus b times a minus b. Now how do we use difference of squares when dealing with roots? Well, what we should notice is this says 3 square root of 2 plus 5 square root of 2 times 3 square root of 2 minus 5 square root of 2. Well, we should notice that we have a and a plus b and minus b. So we can rewrite this as a squared minus b squared. So we will take 3 square root of 2 and square that minus 5 square root of 2 squared. Now when we square this, we're going to square the coefficient and square the square root. So 3 squared is 9 and square root of 2 squared is just 2. So we end up with 3 squared and square root of 2 squared minus 5 squared and square root of 2 squared. Well, 3 squared is 9. Square root of 2 squared is just 2. 5 squared is 25. And square root of 2 squared is 2. So we end up with 9 times 2 minus 25 times 2. Well, 9 times 2 is 18, and 25 times 2 is 50. So we get 18 minus 50, which is negative 32. So this is a simple way to solve without having to actually FOIL this and then multiply everything out and combine and everything. So this is just a simpler way to do it in fewer steps. This one says 3 square root of 2 plus 5 square root of 2 plus 3 times 3 square root of 2 minus 3 minus 5 square root of 2. Well, what we should notice is if we were to group this part here and this part here, it still becomes a plus b times a minus b. So if we rewrite this, this is 3 square root of 2 plus, and then 5 square root of 2 plus 3. And this is 3 square root of 2 minus 3 plus 5 square root of 2. So if we reorder these, which we could, then we see that this is our a, and this whole thing here is our b. So we can rewrite this as 3 square root of 2 squared minus 5 square root of 2 plus 3 squared. So now we can go ahead and multiply this out. So we're going to say 3 squared and square root of 2 squared. And then here we have 5 square root of 2 plus 3 squared. Now with this, we're going to have to actually FOIL it. And when we do that, we get 9 times 2 minus 50 plus 30 square root of 2 plus 9. Now we're going to go ahead and combine these. So this negative sign goes to everything. So this becomes 18 minus 59 plus 30 square root of 2. So that's 18 minus 59 minus 30 square root of 2 because the negative sign's got to carry into everything. We'll combine these. 18 minus 59 is negative 41. And we'll keep this as minus 30 square root of 2. Now, difference of cubes. Difference of cubes states that a minus b times a squared plus ab plus b squared is equal to a cubed minus b cubed. And likewise, we could go the other way and say a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So in this case, we have 3 square root of 2 minus 5 square root of 2 times 18 plus 15 square root of 2 plus 50. And what we should notice is 3 square root of 2, if we square that, we get 18. And if we square 5 square root of 2, we get 50. So this is really a minus b times a squared plus 2ab plus b squared. So we can rewrite that as 3 square root of 2 cubed minus 5 square root of 2 cubed. Now we just cube these, so this is 3 cubed and square root of 2 cubed. And then we have 5 cubed and square root of 2 cubed. And when we do that, we get 3 cubed, which is 27, and square root of 2 cubed, which is 2 square root of 2. And then here we have 5 cubed, which is 125, and square root of 2 cubed, which is 2 square root of 2. So now we just combine these. So 27 times 2 is 54 square root of 2. And 25 times 2 is 250 square root of 2. Now we just combine these like terms. So we get 54 minus 250 is 196 square root of 2. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log into Desmos using Google.
Let's take a look now at the Radical Numbers Part 1 assignment. The assignment begins with our learning goals and success criteria. If we scroll down, there's a link here that takes us to the Desmos activity. Go ahead and click on that link, and it takes us to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. And it says calculate the following numbers and state whether each result is a rational number or not. So we're going to calculate this. We're going to solve these different equations. And whatever we get is our answer. So this first one, we go ahead and FOIL this out. And then we'll put our answer here. And then we're going to decide, is it rational or irrational? Well, we're going to look at it and decide, okay, this is irrational. And so on. So you'll do that for each of these. So you're going to answer each of the questions by solving, and then decide whether it is rational or irrational. So you'll put your answer here, and then we'll click Next. And we'll continue doing this through slides 2 and 3. Then when we get to slide 4, we're going to simplify by adding like terms wherever possible. So we're going to see if there's anything we can pull out to create like terms. For instance, we have 63, which is really 9 times 7. So we could pull out the 9, and we're left with square root of 7 under here. Well, square root of 7 is under here as well. So we could combine those terms. So we're going to simplify wherever possible. Now on this one, we're going to rationalize the denominators. And the way we rationalize the denominators is by multiplying by the opposite here. So this would be square root of 2 minus square root of 5. So if we multiply top and bottom by that, we can rationalize the denominator. Now this time they want us to rationalize the numerator, so we'd do the same thing. So we'd multiply by square root of 7 plus 2, and here we'd multiply by square root of 5 plus square root of 3. So we just multiply by the opposite. And then lastly, we're going to add fractions. We need to get common denominators first. So the easiest thing is rationalize the denominators and then get common denominators and then solve. And then when we're done, we'll go back to our Google form and click Next. This will send you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.